Well, there we go.
Well, yeah, I still am. So this is actually, I know we're doing grade 12 work, right? But remember, this is from a grade 11 textbook. So in as much as this thing here is a double angle, we won't necessarily use double angles for this question. But it doesn't matter because we haven't touched on double angles. So it's okay if whatever it is that's being said now is not necessarily very what you may call, like, don't worry about what I just said. So with with um with this kind of equation, right? Obviously, if you're going to be proving identity, the one thing you normally want to do for yourself is you want to look for the side that may look what you may call a bit complicated. So when I say you want to look for the side that looks complicated, I just mean looking at the left and the right, which side do you think looks a bit crazy or weird? Hello? Anybody home?
My
Oh,
bad. I mute myself. I've gone back to muting myself. I said 1+2.
I mean, well, this side looks more complicated.
They both do. I mean, because okay, actually the bracket as well. Because how do you break down the bracket to get 1+2?
I mean, 1+2 sine. Okay, well, the thing is, you always wanna, in this kind of a situation, right? You wanna ask yourself which side looks like you can at least start and do something. So the right hand side, I mean, not necessarily. We might not be able to really go far. But then the left hand side, I mean, like there's a bracket squared. So logically speaking, you could start by having two brackets and then you just FOIL them out, right?
Yeah.
Yeah, so let's do that. Let's do that. Sine theta plus cos theta, sine theta plus cos theta. There you go. And then we just have to work this out bit by bit. We don't even have to overthink it. So this is left hand side, right? So here's sine times sine. That's like sine squared theta. And then sine times the cos there, that's like sine theta cos theta. And then here also cos times the sine, that's like sine theta cos theta. And then lastly, cos times cos gives us cos squared theta. And then, I mean, if you look at how things are, I'm sure you can see things are just coming together now. Because remember, with identities, what does this and this give you? The sine squared theta and the plus the cos squared theta. Hello? Do you remember? Oh, damn. Hello? Let me pause this thing. I was asking about this, the sine squared theta and the cos squared theta. I was asking if you can see something there. What can that change?
Isn't there an identity for that?
Yeah, there is. There definitely is.
Which is that 1+2 one over there, right?
No, no. I mean, look, this plus this gives you a 1. Okay, remember, there's an identity that says that sine squared theta plus cos squared theta. This is the square identity. It's one of the first things that were laid out when identities were mentioned in the study guide. You see, I mean, in the grade 11 textbook. That's the first thing that is mentioned when it comes to identity. It's called the square identity. It just says a trig ratio sine squared plus cos squared will always give you a 1. So if we scroll up here, you see here where it says, what can we call? Summary of trigonometric identities. There's this one here, tan theta is equal to sin theta over cos theta. And then sin squared theta plus cos squared theta is equal to 1 for all values of theta.
I didn't see that. Okay.
Yeah, so this is what we're referring to.
Ah.
Now, A and B, right, is also true, because here they're also saying this identity can be written in the following ways. Meaning if you have cos squared theta, you can always write it as 1 minus sin squared theta. If you have sin squared theta, you can always write it as 1 minus cos squared theta. You see, this here you can write it like this. This here you can write it like that. It is just that plain. You get it?
I get it.
Yeah. So with what we have specifically, right? This here, this sin squared theta plus this cos squared theta, we can write that as 1. We literally just change it to a 1. And then look here. You see that these are like terms. You see that this and this is a like terms.
Sorry, I stepped away for a second. But yeah, I see that.
Yeah. So this here plus this here is going to give us 2 of them. So this is 1 of this thing plus 1 of this thing. So we end up with 2 of them. You see, 2 sin theta cos theta.
But that one says 2 sin theta times. And then we've got plus. So how's that gonna work?
What do you mean?
The one at the top, it says 1 plus 2 sin theta. Yeah,
What
and then
then what do we have here?
but we have a, that's what I'm saying, we have a plus sign on top. So what happens to the plus sign that made it a multiplication sign?
No, all that has happened is we have 1 of this plus 1 of this. It's just like saying A plus A. What is A plus A?
To A.
To A. Because you have 1A plus 1A. Here, you have 1 of this plus 1 of the same thing. So 1 plus 1 gives you 2 of that thing. You see?
I see.
There we go. There we go. There we go. That's the idea. That's the idea. So that's what you need to just keep in mind with this kind of work. And these kinds of things, they will only make sense if you use them. Because normally if you don't use them, you'll keep forgetting them. You see, you will always keep forgetting them. And when you keep forgetting them, yeah, it's not going to help you much. Really not going to help you much. So that's how you work out this kind of a question.
Okay.